Hello and welcome to another episode of Geography Made Easy. And in these videos, we will try to make difficult geographical topics easy. Today, I will be talking about a new type of syllabus and examination, which is the UPSC examination. It is one of the most competitive examinations in the world. Today I will be talking about optional geography, which is from the mains, and I will try and cover each and every topic in a very simple and easy manner from geography. So today's topic is from the topic oceanography, where we study about the seas and the oceans and their characteristics. And today's topic in particular is temperature and salinity. First, let's talk about temperature. What is the meaning of the word temperature? Temperature is the degree of heat or cold which is present in water. And in this case, as we are talking about seas and oceans, we look at the temperature of the sea or the ocean. So there are two ways in which temperature can be measured, and they are the sea surface temperature, which is the temperature on the surface of the sea, and the temperature changes with depth. That is, as we go down, the temperature changes that takes place. So one is on the surface and the other is a vertical surface. So we have the horizontal surface and we have the vertical surface. We will look at temperatures of both these conditions of the sea. So then this particular map, we can see the surface temperature or the horizontal distribution of temperature. For this particular map, we can see that the map has been given for the month of July. These lines, these iso lines are called isotherms. So they are iso lines. That means they are invisible or imaginary lines joining places having the same temperature. So therm comes from the word temperature. So we see that near the equator, around the equator, the temperatures are very high. We see around, we have the isotherms which are higher. The oceans and the seas which are in the tropical region also have higher temperature, around 25 to 35 degrees Celsius. And as we move towards the poles, we see that temperature falls, and we see that in the southern pole, we see South Pole near Antarctica, we see that the temperature falls down more compared to the northern hemisphere. So this happens because of the fact that the landmass in the southern hemisphere is less and the ocean surfaces are more compared to the northern hemisphere. So what happens? Why does this happen? This happens because land quickly absorbs heat and becomes hotter. Also quickly it loses its heat and becomes colder. So in the tropical areas, that is here and here in Africa and Asia, we see that land is retaining or absorbing the heat and becoming quickly hotter in the month of July. We have the summer seasons in the northern hemisphere. It becomes hotter and the surface, so the sea surface temperatures comparatively is a little cooler because water takes time to become heated. Similarly, we see that water also takes time. Once it becomes hot, it retains the heat. It slowly becomes cool. But once it becomes cool, it retains the temperature. So for this reason, we see that wherever there is the presence of land mass, the land mass influences the particular temperature in that area. That means that it makes the surface hotter, and when we have the oceans and the seas, the surface temperature is cooler. Now we will be discussing about the factors which affect the horizontal distribution of temperature. So we will be discussing about what exactly affects the surface temperature of the oceans and the seas all over the world. The first one is latitude and insolation. And the meaning of this word insolation is incoming solar radiation. So this is basically, in simple words, it means sunlight which reaches the surface of the earth. So near the equator, we know that the sunlight which reaches the earth's surface is much more. The rays are straight, and we know that as we move towards the poles, we see that the sun rays, they become slanting. So this is also a reason why we see that the amount of insolation received near the equator is much greater than the insolation which is received near the poles. So we see that this affects the sea surface temperatures. So this is also one reason why the surface temperature of the sea is much more hotter near the tropical regions than in comparison to the temperate and the polar regions. Next is the prevailing wind direction, and by prevailing wind we mean that the wind which is blowing in a seasonal manner, and it is a wind which is blowing over a longer period of time. So we have, for example, the doldrums, we have the trade winds. So these are blowing, and when they are blowing, the property they have, for example, if they are a cold wind or if they are a warm wind, they are going to affect the surface temperature in that case. The third point is already something which we have discussed in the previous slide, which is the unequal distribution of land and water. So this particular thing is this, we see that in the northern hemisphere the land is much more greater and water is much more greater in the southern hemisphere. And so this property affects the temperature differences which are there in the northern hemisphere and the southern hemisphere. The southern hemisphere is cooler compared to the northern hemisphere because more land is present in the northern hemisphere than in the southern hemisphere. The fourth point is a very interesting point, which is evaporation rate. So more the evaporation, that will affect the temperature because it is either going to lower or increase the temperature. So if my evaporation is high, so if the evaporation is high, as we see in the tropical regions, we see that the sunlight, the insolation received is also high and the evaporation rate is high, and in that case we see that that affects the sea surface temperature. Higher or warmer seas will have a higher evaporation rate and the water will evaporate much more. So it is going to make the surface much more warmer than in comparison to places which have a low evaporation rate like the polar regions. Next, we have water density. We know that the different seas and oceans have different water density, and the water density in this case is dependent on the number of soluble minerals which is present in the particular sea or ocean. So the more the dense a sea is, it is going to be cooler, and the less the dense the sea is, that means the water molecules are much more freely to move, the temperature will go up much more compared to a dense sea where the molecules along with the minerals are close to one another. They are heavier, and it won't be very easy for the temperature of the sun to uh, in a dense water to make it warmer faster. Next is ocean currents. Ocean currents are these streams of water which are present in the oceans, and these streams can be either hot streams or cold streams. So we see that the warm ocean currents, they move over the surface, and the cold dense ocean currents, they move below the surface. They help in transferring the heat between the tropical and the temperate regions, trying to balance out the temperatures all over the world. The presence of cold ocean currents leads to a reduction of the temperature of the sea, and when we have a warm ocean current, it increases the temperature of the sea. So it definitely directly has a role in the horizontal distribution of temperature of the seas. And finally, we can have local factors. We can have certain factors which are very much local. It can be a local wind, it can be a small local current, it can be any other activity. It can also be because of any biological organism which is present there, or any other factor. It can be geology, it can be biology, it can be even anthropology, like human beings. So all these local factors also affect the temperature of the sea or the ocean at a particular place. Let us move on to the vertical distribution of temperature. So now we have been talking about the horizontal distribution, and now we are looking at the vertical distribution. And in vertical distribution, we can see that we are looking at the depth. So from the surface to 4,500 meters depth, we can see that temperature which is warmer, it's nearly around 22 to 23 degrees Celsius. This is the global average on the surface of the earth, and then we see that this particular curve, the temperature dips down and it becomes nearly 4 degrees Celsius at the bottom, deep sea bottom. So the temperature will decrease steadily. So only the surface part of the ocean is warm, and then we see a steady declination of the temperature as you move down. So there are basically three zones which can be recognized based on temperature. The first is the surface or the mixed zone, the next is the thermocline, and finally we have the deep zone. So this is the surface zone between 0 to 350 meters. Then from 350 meters to 1000 meters we have the thermocline, or we have the in between layer, and then temperature quickly becomes very cold when we go into the deep zone. Most organisms are located and we have high biodiversity, especially when we look at the tropical seas. We see that there is a lot of high biodiversity. So this happens because of the temperature. So warmer sea, it can encourage the growth of more plants and animals. More flora and fauna can live in warmer seas. Coral reefs and all the things which we sometimes see on television, as we have seen in television as kids, and now we can see them when we look at National Geographic documentaries. They are showing the surface or the mixed zones, because the coral reefs are seen in shallow seas. We will not see them in deep sea. The thermocline zone is a transition zone between the very cold and the very warm. So we see that the fauna and the flora, they get segregated based on the vertical distribution of temperature, and deep down as we go down, the pressure of the seawater becomes enormous, and we see that not many animals, they will live at the deep sea bottom. Next, we move on to the next topic, which is salinity. So what is the meaning of the word salinity? So the amount of salt which is present in the sea water, it is called the salinity. We know that when we have gone to the beach as a kid, if by mistake we have some water has entered our mouth while taking a bath, we know that the sea water is excessively salty and we cannot drink sea water. So though we have a lot of water around the world, but we cannot use it because the water is very salty. So this salinity, how does this happen? How does this come? From where does this come? So basically the rivers, they bear a lot of dissolved minerals and other different kinds of dissolved minerals. They are born into the sea, and these minerals, they actually also, we have of course, so calcium, we have sodium, and we have the common salt which is also extracted from the sea. So this is NaCl, and every other mineral is deposited in the sea, and then it mixes with the seawater and makes it salty. So the salinity is measured with the help of the unit gram per 1000 grams or gram per 100 gram. So when we have the measurement of gram per 1000 gram, it is called parts per parts per parcel. So sorry, I said parts per, it is called parts per 1000. So it is written in this manner. This is the symbol for this particular expression. But in this case, the values which we have got, they are just three indicators of how much saline a particular sea or ocean can be. So this is based on this gram per 100 gram and not 1000 gram. So we can have Dead Sea, which is 33.7, which is very salty, compared to Mediterranean, which is 3.8, and we have Caspian, which is just 1.25. Let us move on. So here we have the particular diagram where they have shown that the what we call when we are talking about fresh water. So fresh water is 0.1 ppt, parts per thousand. Then they have put in some indicators of Baltic Sea, Black Sea. Then we have the brackish water, like we have the water which is there in the estuaries, mangroves, swamps, which are again we cannot consume. We can only consume this, and this water is very limited on the surface of the earth. So brackish water is around 5 to 30 ppt. Then we have the sea water, the salt lakes, the saline water, and finally we have the excessive saline waters, which are called the briny waters, which are very saline. The percentage of salt in the briny water is very high. And we will now look into why are oceans saline. I have already discussed that salts and minerals from the land, they add to its salinity. Salt from deep sea vents. So we have these deep sea vents inside the ocean near the mid-oceanic ridge, which they give up out sulfur fumes and other minerals which are coming out from these fumes. So these sulfur fumes and the other minerals which are coming out from the vents, they mix with seawater and they also contribute to the salinity of the ocean water. And I have written parts per thousand. So this is the symbol for parts per thousand, and or it is expressed as pp. So now we will be discussing about the factors which affect the salinity of the ocean water. The first factor is rainfall. So when we have rain falling, which is of course water which is not salty, rainwater is uh, it's quite it's not salty, like it doesn't have much salt content. If it is having salt content, then it will be very less. When we have rainwater falling on the seawater, it makes the water dilute. So in that case, we see that the salinity will reduce where there is high rainwater. Let us look at some examples. If I have two glasses, that is glass A and glass B, and in glass A, if I'm adding, and in glass B 3 tablespoons of salt, and I'm filling the A glass with water, with half water, and I'm filling B glass with full water. And if I taste the A glass water and the B glass water, the water in glass A will tend to be more salty than glass B. And this is the reason, because the amount of water present in B is greater. So the water molecules, it mixes much more in the glass B than in glass A. So this is the reason why rainfall affects. More rainfall, salinity goes down. Next is evaporation. In places, so rainfall is when we have the addition of water, and evaporation is the loss of water from the surface. So when there is very high evaporation, the particular sea or the ocean will become salty. because it is the water molecules is lost to the atmospheric system. Then what happens, the salt it is getting left behind. And so this is the reason why we see that in deserts, and we see that the Dead Sea, the Black Sea, the amount of salinity which is present is much more. The inland seas which are cut off from any kind of source of fresh water, and there's not much rainfall and the evaporation rates are very high because it's hot, we see that in these places the salinity goes up drastically. Next is river water recharge. So when there is river water which is flowing into the ocean or the sea, the river water is not salty or not brackish, and we see that when it is getting added to the particular your sea or ocean, we see that the salinity will go down. So, for example, the Bay of Bengal has a less amount of salinity compared to Arabian Sea because a large number of rivers are flowing into the Bay of Bengal in comparison to the Arabian Sea. So, salinity varies between the Bay of Bengal and the Arabian Sea for this reason. Next is the ocean currents. There are ocean currents which can carry away or which can bring in saline water into a particular place. So they can affect the salinity in a particular area. Atmospheric pressure and wind direction are not so important factors for contribution to salinity, but we will still talk about them a little bit. So the wind direction, that is again in which direction the wind is blowing, and if it is blowing from a saline seawater to a less saline seawater, or from land and it is bringing in a lot of salt deposits into the sea, it can also indirectly affect the salinity of the seawater. Atmospheric pressure, I would say, is the least important in this case, but also it has an impact on the seawater as well. But the most important of the factors which affect salinity are rainfall, evaporation, and river water recharge. Let us just look at the three main oceans which are there in the syllabus, and let us look at the salinity rates which are present in the three oceans. So we have the Pacific Ocean, we have the Indian Ocean, we have the Atlantic Ocean. All these three oceans are very, very large oceans, especially Pacific and Atlantic, and the average salinity hence is for most cases 35 to 37. Atlantic ranges from 36 to 37, and these are averages. There are certain places which can have more high salinity, there are certain places which will have low salinity. Because it is such a large ocean, we can negate the highs and the lows. Indian Ocean has an average of 35 and Pacific Ocean 37, and I've written the reasons. So for Pacific Ocean, it's a large ocean. Local conditions, they vary a lot. It's a huge ocean, and if you have watched the movie Life of Pi, you know that how they've shown depicted Pacific Ocean, and we know that it is such a large ocean. The climatic conditions, the salinity conditions, the wind blowing, the pressure conditions, everything varies a lot, and it keeps changing. It's very dynamic from one part of the Pacific Ocean to the other. Next, we have the Indian Ocean, where the salinity actually is less, and this is because of the influx of rivers, which in the previous slide we saw that it is one of the most important reasons. So a lot of the salinity gets reduced because some of the world's largest rivers and the entire river system, three rivers which are bringing in a lot of sediment and fresh water into the ocean through the Bay of Bengal, and they are the Ganges and the Brahmaputra systems, along with the southern Indian water rivers also, but it is mostly the Ganga Brahmaputra delta system, the Ganga Brahmaputra river system, which actually brings in tons, millions of tons of river water into the system every year. So the salinity goes down. For Atlantic Ocean also we have, it's a large ocean. It is traversing in the northern to the southern hemisphere. So there is a lot of, again, local conditions can, vary, or it can affect the salinity in certain places. So factors such as the wind directions, rainfall, humidity, they all affect salinity. So, do you have any doubts or questions regarding this chapter? Please feel free to write to me in the comment section and we can discuss about this. If I have missed out on any topic which you are finding in this particular chapter difficult, please also let me know so that I can maybe make a short video, or I can make shorts on that particular topic and try and cover it up. And if you are liking my video, please like, share and subscribe with your friends. And let me know how you find, whether you're finding the UPSC videos useful or not, so that I can make more and more videos. And see you in the next video. Bye.